The DARPA SubTerranean Challenge is a $5 million competition for developers to create the most autonomous, rapid response robots possible, capable of performing tasks in abandoned or ruined tunnels, caves, and underground passages where GPS and communications are not available. These robots can find or hide things underground that the U.S. Office of Advanced Research would like to get their hands on. Learn more about these challenges as well as other DARPA robots in today's one episode. The SubT challenge began in 2018 and consists of 2 tracks, a physical track and a virtual track that are divided into 3 locations: a tunnel, a city, and a cave. In 1 hour, each team's robot must find 10 artifacts, from a mannequin radiating heat to an activated cell phone. The robots from each team, regardless of their number, can be assisted by only one operator, but that operator's participation is reduced to high-level commands and confirmation of the correct artifact found. All of the rest, the robots must do themselves, and the masters of the dungeons, that are the organizers of the challenge, can change the environment. For example, completely disabling the network and setting traps for the robots. Let's take a look at what each team was betting on and which strategies were successful. Coordinated Robotics from the US was one of 2 teams at the challenge without a major sponsor, and therefore the engineers had to use budget robots, but this generated a lot of creative solutions. For example, the team's robots used Ariande's thread, unwinding the fishing line from the spool, carrying the drones, and leaving beacons for each other to coordinate actions. If a large robot got stuck in a passage, one of the smaller ones would try to go around it and continue the search. Unfortunately, this didn't help the team win. The CoSTAR Team from US, South Korea, and Sweden won the challenge last year by using the Spot robot from Boston Dynamics. Other teams picked up on this, and there were more than enough spots on the SubT this year. CoSTAR also prepared and bet on a combination of 3 different mobility systems. The team's robots had to set up their own roles, sharing the tasks of searching for artifacts and communicating and coordinating with each other. Engineers tried to develop software that would make the robots completely independent, but something went wrong, and the CoSTAR robots mostly created a show of fuss. Spots and wheeled robots stomped on drones, clashed with each other, and apparently had a fight for their own autonomous alpha bot. The CTU-CRAS-NORLAB Team from Czech Republic deployed all kinds of ground vehicles, tracked and wheeled platforms, walking robots, and drones. The main bet was on a communications network to connect the robots with each other, which was laid by the machines themselves. The strategy was not the most successful, and the CTU-CRAS-NORLAB did not take a prize. The Explorer team from the United States also tried to present a large variety of platforms on different sizes for any terrain or circumstance. The robots were autonomous, they could coordinate their efforts and search for artifacts, but the operator monitored their work and helped them get out of some difficult situations. Explorer had the most confident and helpful drones at all, but despite all the popular belief that drones are the perfect ones for SubT, it didn't bring home a win for the team. The most modest team at the challenge was the Robotika International from the Czech Republic. It brought only 2 compact robots, which were the easiest to get into the US. The robots could move forward and backward and had sensor cameras mounted on both sides and were equipped with their own neural networks for self-discovery. But again, this was not enough to win it all. So, who won at SubT? Well, 3rd place went to the Marble team from the USA. The engineers developed a strategy where Spot's robot walked ahead of the robot team, defining the general boundaries of the space and finding all areas available for exploration. He was followed by a team of assorted robots sharpened to search for specific elements and data like thermal radiation or cell phone signals. The robots did not depend on communication and shared data with each other, and each robot did not rely on the others and could disconnect from the network and follow its own autonomous search program if needed. Coming in at 2nd place was the CSIRO Data 61 team from the US and Australia. The engineers relied on the BI-A5 ATR-tracked robots, with the perception and navigation of Spot robots, Emessen's custom-designed SubTerranean Navi drones, and a new smart node for communication, which were dropped from robots and automatically deployed, extending the ground plates and antennas. The robot fleet used a common sensing, mapping, and navigation system for all robots built on the Wildcat SLAM technology, and as a result, the homogeneous perception on heterogeneous platforms paradigm gave the team an advantage. The robots acted completely autonomously and tried not to intervene with each other, for which the robots were prioritized. However, there were some failures along the way, and this team fell just short of winning, taking second place. And finally, first place went to the Cerberus team from USA, Switzerland, Great Britain, and Norway. And this is the first conditional triumph of the Animal C robots over Boston Dynamics Spot. Conditional because the whole strategy of using dog robots and drones, as well as the engineering achievements of the developers who created the new equipment for SubT, turned out to be a winner. All robots had two modes, full and controlled autonomy, in which the operator could observe and undo some of the robot's actions. In the end, neat, moderately autonomous, and attentive due to a multitude of sensors, the machines were able to pull off a victory. Today, flying robots and drones such as Predators, Reapers, and other autonomous skyborgs developed for the Air Force to act as a wingman for human pilots in combat situations are prevalent in the US military. Drones are popular because in addition to taking off and landing, they also keep from colliding with many objects and other hazards that might affect land travel. Following the airborne, underwater robots are making their way into the military as well. They can maintain underwater communication, conduct research, or be scouts and carry munitions. Underwater drones rarely encounter anything, just as they do in the air. Now, ground robots are more difficult, especially in cities or rugged terrain. Yet, more often than not, they have access to communication, lighting, data, such as from aerial drones and so on. Robots underground are quite another matter. Nevertheless, DARPA is trying to master underground space. And while the agency is trying to conquer ready-made tunnels and caves with SubT, it's launched an Underminer to master the invisible underworld. The goal is to develop a tunneling robot that could navigate the underground world without human intervention, and such a robot could work as a minesweeper or delivery of ammunition. The first prototype was created by GE Research, which received $2.5 million from DARPA. The robot is able to dig tunnels along a preset path, making sharp turns and getting to the desired point all by itself in autonomous mode. We've talked more about DARPA robots and tech in the video here at the tip. While you're here, subscribe to the channel, like this video, and let us know in the comments what other robots do you want to know about.